Annalise Barnett, Associate Marketing Manager at BD. And for today's Ask the Expert session, I'll be having a chat with two of our BD experts. But before I introduce today's experts, I would like to share a few housekeeping items. So if you have any questions during the webcast, please submit them through the Q&A widget of your console, and we have experts ready to answer them on the back end during the event. For the best viewing experience, we recommend using a wired internet connection and closing any programs or browsers running in the background that could cause some issues. And you can find additional answers to some of these common technical issues located in the Help Engagement tool at the bottom of your screen. And then lastly, a recording of this broadcast will be made available, so look out for an email with additional details on where to access it. Now, let me introduce our speakers. I am thrilled today to be speaking with two of BD's very own flow cytometry veterans, Dr. Alan Stahl and Dr. Marybeth Sharkey. Alan has been working in flow cytometry since 1978 and is currently a principal scientist in the R&D department at BD Biosciences. He has been the R&D lead for the teams that developed the cytometry setup and tracking system incorporated in the CS&T beads, FACSMatters software, FACSLyric FACSuite automated assay setup system, and more recently, the development of the BD Horizon guided panel solution to help investigators with assay panel design. And Marybeth has held the role of Director of Systems Technology at BD until her retirement last year in 2019. And in this role, she acquired multiple patents in the areas of new technologies and reagent methods supporting the use of flow reagents, dyes, beads, liposome standards, and instrument applications. She has focused her efforts on platform standardization with the goal of enabling researchers and clinicians to clearly separate the biology from the inherent variables that impact flow cytometry. With the introduction of the Lyric platform, with its enhanced standardization capability, is an example of the quality work she has brought to BD Biosciences. So thank you both for joining me. And today we are talking about CS&T beads, standardization, and what it means for scientists in the lab day-to-day performing flow cytometry. And I want to start with a bit of background on what drove the need for CS&T bead technology. And Marybeth, I'll start by directing that question to you.
Thank you. So, as you know, BD has been very committed in bringing forth a platform that will give reproducible results over time. Our first platform in that area with a secure setup was the Caliber. And of course, back then, people thought 3 colors was something quite unique and different and was challenging for coming up with immunoassays. It eventually was expanded to a 4-color system. And the challenges of compensation when you're dealing with 3 and 4 colors is, of course, trivial in today's world when we look at going up to 30 colors. So the type of bead and control system, which is a marriage of the instrument design, the software that runs the platform, as well as the particles we design, was our first step in the door for trying to standardize a platform to create an ease of use for our customers. The Caliber course was launched in about 1990, so it's a very old platform. It's still in use today quite robustly, and its next new replacement in a standardized setup was our Canto system. And in the clinical space, we designed a 7-color setup bead, which was an improvement over the Calibrite bead application. However, at that time, we were only looking at 6, 7 colors. And as you all know, we didn't have a huge variety of dyes. So what we were asking for the system was matched and accommodated by that technology. But it's a whole new world out there. When you're looking at 30-some colors, you need to rethink how it is that you're going to view your technology to ensure that our customers can get beautiful, reproducible results that exhibits the biology of the patient as opposed to the complexity of the system. In order to achieve something with that type of excellence, we had to rethink how we were going to design beads, control the instrument, and interact software, instrumentation with the bead, and hence our next product was the CS&T bead that's in current use today.
Perfect. Thank you, Marybeth. And then, Alan, I will give you an opportunity to add to that if you have anything else to say.
I think Marybeth said that very excellently, and I don't have too much to add to that. What was driving the need? What was driving the need was we were, at the time that CS&T came, we were embarking on a brand new world of more and more colors. So we had been living at around, as Marybeth said, around 7, 8 colors, but now we were beginning to head into the world of 10, 12, 15, 20 colors.
Right, and I think that leads nicely into our next question. And Alan, I want to direct that one to you, and that is about what is unique about the CS&T bead technology, and maybe we can share some of its applications.
There are 2 aspects that are unique to CS&T. The first is that previously to this point, the beads that we had been using were simultaneously used to set up QE and set up compensation for our instruments. So that was true of the beads for the caliber and true of the 7-color beads. As we were going forward in, again, having 10, 12, potentially 15 colors, we knew that we could not use that same model system of having 1 bead per 1 die and dissecting that. So we made the decision at that time that we would go to hard dyed beads, which would do the setup and calibration and then have compensation separate. So the unique characteristics of the CS&T beads is that they were a bead that had multiple dyes embedded into it that allowed it to be excited by all laser wavelengths available at the time and emit in all the detectors, which at the time was about 10 different detectors. The unique thing about it is the way we designed it is that now it still works with 18 detectors, 20 detectors. The second thing that was unique about the CS&T beads was that at that time, we started implementing some metrics that had been developed by Bob Hoffman and Jim Woods, which were the concept of instrumentation Q and B and electronic noise. And so the beads were designed with 3 different levels, which would allow us to then calculate all of these metrics. And those metrics were very valuable for users to be able to qualify their instrument and identify where problems would go wrong. So each of those pieces of information gave you insight into what was happening for a given detector. So that together gave users a much faster and a easier way of looking at their instrumentation.
All right. So, and Marybeth, feel free to jump in here if you have anything else to add.
I think Alan has done a nice job summing that up. Using a CS&T bead, one of the criticalities from a design standpoint was the reproducibility of the bead from lot to lot. This is something that's always challenging with bead technology. And what BD is uniquely able to do is to leverage their software interaction from a system perspective. So remember, when we talk about CS&T, we talk about any of the beads we make, one of the core advantages we have is that interaction. So we've created a bead that remarkably has very small absolute differences in dyes lot to lot, which is exceedingly challenging from a technical standpoint. But when we marry it with our software, we can make those changes invisible to the impact to the customer using the platform.
So to build on that concept, another point that I didn't mention is at the same time we introduced the concept of ABDs, or assigned BD units for each bead for each detector. And as Marybeth had said, what that allowed us to do is to normalize all of our data between lots so that we could, for any differences from lot to lot variances, we could adjust it based upon the software. So that was a very, very important aspect of this.
And historically, on our pre-lyric platforms, our focus is exactly what Alan said. So it's within instrument, setup, reproducibility, and invisibility. When we move over to the lyric, we're always trying to do a one-uppance with ourselves. Yep. Looking at what's most challenging when we're running our panel reagents here. So what we were able to, with a lot of effort, to do from a design standpoint is make that CS&T setup very close to identical platform to platform. And that is a very unique attribute that we can offer with that lyric system.
Yep. Good. I think that's a good discussion, but before I continue to hear from our experts, we want to hear from you, our audience. So we'll be pushing out a few poll questions right now, and there'll be two, and you'll have 30 seconds to answer them. So be on the lookout now for the first poll question is going to come out. So we can get some insight from you as well. I think going back to our conversation, I think both of you have started to talk about how, where CS&T technology began and a little bit about how it has evolved. And Marybeth, I want to go back to you to talk maybe a little bit further about how that technology has evolved over time.
Okay, so I'm going to break this into three sections for total awareness. We have a bead particle, we have a software system, and we have an instrument. So BD has moved to improve the CS&T beads. For example, when they first came out, we realized that there were more significant differences than we wished to see platform to platform on the individual bead performance, particularly in the violet space. So over time, what we did is we readjusted all of the dyes, and this is fairly early when CS&T was initiated, to be able to normalize or to approach normalization of how different systems viewed the beads to make the setup a little bit better. But over time, let me be very clear, we also improved the software. We also improved the lasers. We also improved some of the fundamental design of the instrument itself. What the customer sees as they're running the instrument is how those different variables wrap up and how we see a much more smoother, reproducible result from a CS&T over time. So I always like to do that caution. Remember, a bead is a bead, piece of plastic with dye in it. There's only so much an improvement you can do with that aspect, but we marry and improve all portions that impact the bead and its setup. And all of our teams are very dedicated on brainstorming and coming up with significant improvements so that the experience by the customer is improved.
So to build on that, one of the differences in terms of the use of the CS&T is it is a whole system. And Marybeth has made this point, and I would reemphasize it, that the benefits and power of what we've done is by marrying the software with the beads, with the instrumentation. So, but there is a fundamental difference in the early stages of CS&T as it is associated with the DIVA software and CS&T as it is now associated with the FACS Lyric and the FACS Suite software. And that is the original design of the system was to optimize each instrument independently and not necessarily try and make every instrument look identical to each other. As we moved forward, and based upon feedback from customers, we then adapted the technology in FACS Suite to really focus on making sure that the instruments were performing equivalently from instrument to instrument. The second thing is that, if you remember, I said that when we first started developing the CS&T bead, we divorced the setup and QC part from the compensation part, which had been part of beads previous to that point. With FACS Lyric, we sort of brought that marriage back together with still maintaining the CS&T, but then with the addition of the FC beads specifically designed to implement compensation. And that would be another whole seminar's worth of discussion on the FC beads.
And the FC beads are one of my personal passions. So anytime anyone wants to ask questions about that, please feel free. I'm very proud of that bead and what it delivers and how that enables the cross-platform standardization and what we've seen in terms of impact of customer results during preliminary clinical trials, trading assays between facilities, using those at particular customer sites that are doing clinical trials, are doing human studies. The impact is remarkable, and for BD to enable this type of technology to be available to everyone on the Lyric platform is tremendous. One of the main complaints or problems or frustrations we hear at conferences is, I ran the assay this way, how come my results are not looking at all like they look at Joe Blow's results in Timbuktu, Kalamazoo, Baltimore, Maryland. And these kinds of very frustrating aspects that disable our researchers from looking at the biology have been overcome by using the FC beads through more normalization, assuming that the technique that's used at the customer sites are identical and the quality of the reagents that are being used at the customer site are equivalent.
Yeah, so I think that we've talked a lot now, Marybeth and Alan, about, what's driving the need. I'm glad you're mentioning now how, with scientists, how that has impacted them. But I want to come down to just the level of the day-to-day with CS&T technology. What does it mean for the person in the lab? How is it helping them? What is the impact on instrument performance? Can you talk a little about that? And I think I'll start with Alan on that one.
As Marybeth would say, this is my favorite topic, and actually one of the reasons I joined BD. So before I say that, I'd like to make one paid political announcement, which is I think the whole CS&T system, whether on DIVA or Lyric, it is the whole system. And it's a little bit like chess. At one level, it's very easy to learn and very easy to utilize, but there's a lot of nuance, and it takes a while to become perfect or expert. And I encourage people, if they have questions, to go seek out our TASs and other experts in terms of how things work on their systems. Now, to get back for scientists, I've been doing, as Annalise said, I've been doing flow cytometry for a little over 40 years now, 20 of them as an independent researcher, academic researcher, before I joined BD. So this system was, in fact, my dream of having to set up instruments. So historically, especially on our cell sorters and some of our more complicated instruments, it could take you 30, 40 minutes in the morning to set up the instrument and optimize it and make sure that it was performing correctly. The goal of the system, which I think we've achieved, is with CS&T, literally, you can put a set of beads on in the morning, press a button, and 5 minutes later, the instrument has been set up, and you know exactly how it is performing. So it really makes a major difference. And the other aspect of it is sort of twofold. One is proactive, and the other is reactive. From a proactive point of view, one of the features built into the CS&T system and into all of our QC systems is the concept of Levi-Jennings. And these are plots that show you how instruments change over time. So with all the different metrics that we were able to get out of CS&T, users can then follow and see how their instruments are changing and then make corrective actions before it begins to impact their data. On the post-experimental side, I remember I used to run a core facility, and people would come into me and go, well, why didn't this experiment work? Clearly something was wrong with your instrument. And I could go back into my reports and go, no, here's the data. The instrument was performing absolutely perfectly. It had to be the cells that were different. So, and conversely, you might see that on that day, something did go wrong with the instrument, and that was what was affecting your data. So it effectively does two things. It gives users much more consistent data, manageable data, and it gives them control over their instrumentation.
Right. So I think all of those are good things. I think it's as you're mentioning, troubleshooting. It really does impact that a lot and makes it a lot easier for scientists as they're doing these QC checks and with a daily basis. And then I know there's 6 months characterization using the CS&T beads. I think I want to now ask both of you, pick your brains a little bit. We talked a little bit about what's driving the need, the explosion of colors. People aren't doing 4-color experiments anymore. What do you think about the future of standardization and maybe just flow cytometry in general? I just want to get a look to the future from you. And Marybeth, I'll start with you.
So from my perspective, the future is limitless in terms of where we can go. I think some of you know that I've been working with collaborators around the world prior to my retirement on extracellular vesicles, and we've been able to successfully elucidate those small particles. This opens up a whole nother area of research looking at the cell signaling mechanisms, which is now believed to be linked to the content of the extracellular vesicle. Also, my team, unpublished work, but I have patent applications in this area, is around viral flow. And being able to understand that in a viral situation, this has been demonstrated by other researchers, that you can see extracellular vesicles that are involved and linked with the blocking of a virus to enter a cell versus the enabling extracellular vesicles from cells that already contain a particular virus. The sky's the limit on the application development of flow as we continue to increase the capability of our platforms. Now, if you think about, I'm dealing with the cell, which is over 1,000 times larger than particles in this space, what is the impact of setup? Setup is even more important as we open up the world and begin to reveal new applications for flow cytometry. Now, that does not mean that we already got to the end-all be-all in terms of cellular research with flow cytometry. We have the capability of drying our reagents, for example. And when you're going through a multi-year clinical trial and you have an instrument that performs identically, and you have a reagent that will perform identically over that time frame, at least in the research that we've done on our dried reagents to date, and you add to that either a frozen PBMC or a dried control cell. Some are pretty good on the market. Some of those have challenges. But now you can see, how does my system work? How can I have a practical QC method that tells me whether or not I should proceed and demonstrates the quality of the reagent? This is really important. Nobody wants to spend lots of time trying to justify variability in a clinical trial and say, if you can have exact data to say, I'm set, I can run, I can do these samples, I can have 100% trust in the validity of the biologics that I'm seeing. That's a place that we are approaching and where we need to go with standardization, in my opinion.
So for me, it's been interesting because the first instrument I worked on had forward and side scatter in 1 color. Now working on instruments that do 30 and more colors. And the fun thing has been that literally about every 10 years, you hear, oh, we have enough colors for all the markers we ever want to look at, and flow cytometry is going to be displaced by other technology. And in 5 years, people will not be doing flow cytometry. I can't tell you how many times I've heard that stated by experts in the field, always proved wrong. And we're at another turning point right now. It's a very exciting time for many aspects. The future flow cytometry is a combination of more power and easier to use and easier to gain and understand information from the data that you acquire. So that in terms of power, we're still making new dyes, and new dyes are now available every single year so that you have the possibility of looking at more parameters. The more parameters means that you have more data and the data becomes more complex. So what we're seeing now is an explosion of new methodologies and software for doing analysis, which is very powerful. In terms of ease of use, for example, BD now has the ability to acquire data, identify populations automatically, and then the software will then put the gates around the parameters you need to sort that population. So you no longer have to manually think about, well, do I gate it between this population and this population? And how do I do my gating hierarchy? All of that's done automatically. So you collect your data on an instrument, a sorter, you port it over to FlowJo, it analyzes the data and exports your gates back to DIVA to do your sort, all without you having to know exactly what you want to do or the best way. So you might have 10 parameters. Let's say you have 15 parameters, and you go, oh, I have to use each of these parameters to sort my population. But you export the data to FlowJo. FlowJo says, no, you only need these 8 parameters to do your sorting gate to get the same amount of quality as if you were doing 15 parameters. So again, the ease of use and the way to go there. The other major thing, which is on the horizon, no pun intended, but is spectral flow cytometry. And that will be a game changer, both in terms of instrument setup, instrument QC, and the type and quality of data that we have. And we're pushing the forefront of that, and that's something that we're always thinking going forward.
And another piece that we've done with the FC beads is I've worked very closely with NIST, and we now have MSF values associated with those beads. This is in the future. We're not ready to roll that out today. But when you think about, I want to look at antigen density, no, it's not as good as having a Quantibrite, customized Quantibrite per color, where you can read off a curve. However, it is a point in time where you can see and quantitate your antigens on a particular cell surface. Well, not exactly, I shouldn't say, but you have a fudge factor. So you're getting into the ballpark, and it's bringing us closer to truth in terms of the characteristic of the cell.
And to that point, I think that also is an aspect of this is that flow cytometry is becoming more quantitative rather than qualitative. So
Correct.
We've all lived with MFI for the last 40 years, but MFI on one instrument is different than MFI on another instrument. We've tried to normalize that using CS&T and have done a very good job. But the truth is, you don't want to know the medium fluorescence intensity in some arbitrary unit. You'd actually like to know how many molecules of something is binding to it and be able to compare the fluorescence intensity from one instrument to another instrument. And that is coming forward. As Marybeth says, it's being driven by NIST as the uniform standard for all of flow cytometry around the world, and we are actively part of that. But again, better data, more qualitative, quantitative data, and easier to get at the final analysis.
Wow, so I heard a lot of ease of use coming out, and I think that's going to be important as we seek to answer more complex questions in biology, and as we talk about spectral and other ways of analyzing that. So I think that this was a wonderful discussion. I want to thank the audience for joining us and listening in and for sharing their thoughts with us in our poll questions. We will be giving CE credits, so please look out for an email for those who attend. The recording will be made available for you via our BD Biosciences YouTube channel, and then also on bdbiosciences.com in our webinar section. And so thank you so much, Marybeth and Alan. This was a great chat, and we look forward to seeing our audience again on another webinar.
Thank you, Annalise.
Thank you.